back to our digestive portion. As the bolus finishes its voyage down the actual esophagus, its first little doorway, okay, or its first little circular ring of muscle that's always closed, okay, unless food is pressing on it, then it opens, is called it's called a sphincter. You have these all over your body. Okay, and so this doorway right here is actually called your lower esophageal sphincter. And the cool thing about this sphincter is it stays closed. And it's a really good thing that it does, because the pH of your stomach is one of the most acidic environments on the planet. Okay, it's got a pH of about 1 or 2. The pH of your esophagus is about a 7. Okay, and we know that pHs, every number lower is a power of 10 more acidic. So that implies that the stomach is anywhere from 100,000 to 1,000,000 times more acidic than your esophagus. So when you throw up, okay, you actually burn part of the lining of your esophagus in your mouth. And the way your body prevents damage is that, remember I told you had mucus in your mouth? You also have mucus lining the inside of your esophagus that not only lubricates food on the way down, but it also helps protect the actual soft tissue that makes up your esophagus. Now, this sphincter stays closed all the time unless food or liquid is coming in. And when it comes in, the stomach is a ridiculously well-oiled machine. Okay, the stomach is unbelievably efficient at what it does. And inside the stomach, it's totally lined with a really thick layer of what to protect it? What does the protecting? Mucus. Your stomach has a very thick layer of mucus inside it. And the cells on the inside of your stomach secrete that mucus, because the liquid on the inside here, okay, this soupy mixture inside here that's got all your food bits is full of 2 very harmful and toxic substances. Okay? Substance number 1 is HCl, also known as hydrochloric acid. And hydrochloric acid does 2 things. Number 1, it finishes the actual digestion of carbohydrates that amylase started, and it starts the digestion of fats. By the time the actual bolus gets into the stomach and it gets mixed in with the gastric juices, that soupy mixture is not a bolus anymore. Okay, that mixture inside, that liquidy mixture inside your stomach is actually called chyme. Okay? This is called CHYME. And we will refer to it as chyme for the rest of the way until essentially it gets to the rectum. Okay, where water is absorbed out of it. All right? In the large intestine and the rectum. We'll get to that later. So here's the cool thing about the stomach. There's a lot happening in the stomach. The stomach also is the site of 2 forms of digestion. What were those forms of digestion again? Chemical and physical. Chemical with these actual gastric juices mixed into the food and help break down the big nutrients. But physical also, because the stomach is a ginormous muscle. Okay, it is lined with a tremendous amount of muscle. And these muscles are continuously contracting, relaxing, contracting, and relaxing. So the muscles are in charge of contracting, and the stomach actually shrinks in size and gets larger. And that helps kind of physically pulverize the food, in addition to allowing the gastric juices to mix in and chemically digest the actual food. So here's the deal. Your stomach has 2 major functions. Number one, it digests. And number two, it's also a place that food is stored. Okay? Because what ends up happening is at the other end of the actual stomach, you have another little sphincter. And that sphincter is known as your pyloric sphincter, because the lower portion of the stomach is called the pyloric portion. I didn't make these names up, but that's what they're called. Okay, so this pyloric sphincter right here opens a little bit at a time and lets food out of, or lets chyme out of the stomach into the duodenum. Okay? As chyme is excreted into the duodenum is part of the small intestine. And the pH of the stomach here is a 1 or a 2, and the pH of the small intestine is about a 7.2. So the intestine itself, yes, it's got a very small layer of mucus coating, because everything does, but it's nowhere near powerful enough to withstand the acid of the actual stomach. So something has to be dumped into the actual duodenum to counteract the acid of the chyme. And that's where this flat organ underneath the actual stomach comes into play. For digestion, its role is simple. Okay? Does anybody know what this organ is called? The pancreas has a couple jobs. Actually, it has several jobs. But for digestion, its main job is to dump, okay, you'll notice how there's a little shunt here. It's to dump sodium bicarbonate into the actual duodenum. Sodium bicarbonate is baking soda. Okay, sodium bicarbonate is a very basic substance. And when you mix a So the pancreas's job is to secrete sodium bicarbonate and dump it into the actual duodenum. Okay? By actually dumping sodium bicarbonate into this duodenum, it's going to mix with the actual soupy chyme that's coming into here with that low pH. And it's going to raise the pH to about a 7 or so. Because when you mix a strong acid with a strong base, they kind of take each other's harshness away and they meet in the middle. And when you're talking about pH, meeting in the middle means being neutral. So what ends up happening here is as the chyme comes in, its pH is neutralized by the actual sodium bicarbonate. Okay, so that's NaCO3, right? Now, that might actually be Na2CO3. I don't remember. I need to go look it up. But regardless, it's sodium bicarbonate. Now, the other thing that happens here, because this, remember, this is still considered the digestive part of the digestion system. So more digestion still has to happen. We know that our carbs are done. We finished them in the stomach. Okay? We worked on our proteins in the stomach. Pepsin will continue to work in the duodenum. Okay? Fats, however, only got started in the stomach. Fats need to be finished. And here's where the largest organ, or one of the largest organs inside your body, known as the liver, okay, comes into play. Because the liver secretes a very basic, no, it's not even, slightly basic substance that is a mixture of salts, it's a mixture of fats, and it's a mixture of dead red blood cells called bilirubin. Okay? And this mixture goes from the liver to this nice little green organ here. Does anybody know what that green organ is called? It stores bile. It's called your gallbladder. Excellent. And it's important to remember that your liver makes the bile. The gallbladder stores the bile so that the bile can be continuously dumped into the digestive system, okay, into the duodenum, because fats are constantly coming through here. And if you've ever actually had a greasy pot in your sink and you've been doing dishes and you've actually dropped a little bit of dish soap into that, you see that the grease repels itself from it. The whole purpose of soap is to emulsify or break down grease. Well, that is exactly what bile does. Bile emulsifies fats in your system and it finishes the digestion of fats. So by the time the duodenum is done, fats, carbohydrates, and proteins have all been broken down into their smaller absorbable parts. Okay? So what happens here is the gallbladder dumps bile into the duodenum. Bile breaks down the fats. The proteins finish being broken down. pH is neutralized slightly by the gallbladder, but mostly by the sodium bicarbonate from the pancreas. And by the time this soupy mixture, this chyme, makes its way into the rest of the small intestine, it is ready to be absorbed. All those nutrients that our body so desperately needs are going to get absorbed. Okay? Interestingly, you can live without your gallbladder. The gallbladder is nothing more than a storage organ. Okay? It does not produce the bile. So if someone has their gallbladder removed, then gallbladder removal is actually the most common form of surgery in North America. Okay? It takes about an hour and a half, not even, about an hour to remove somebody's gallbladder through laparoscopic surgery. Laparoscopic surgery is when they actually cut you open. If you've got your innards here, they'll make a cut right here, a cut right here, and a cut right here, and they'll cut open your belly button, and they'll actually go in and using a camera, they'll remove your gallbladder and take it out of the actual hole where your belly button is and sew you up. And the difference between that kind of surgery and old school cutting you up here is that you are walking around, the day of your surgery, as opposed to having a huge scar and being out of commission. Now, the cool thing here is that you can still eat fatty foods, okay, with no gallbladder. You may just not be able to eat as many in one time. So case in point, something like fish and chips. Okay, fish and chips, fish that's fried, chips are potato fries, right? That's a highly fatty meal. So if you're not producing as much actual bile as you normally would have with a gallbladder, it also excreting stored bile, maybe you only eat the fish. Maybe you only eat the chips, or maybe you eat less of it. Because when you can't digest fat like that, it actually can give you cramps later on in your small intestine, and it can lead to diarrhea and things like that. Okay? So all of these digestive organs are very important, and they facilitate not only chemical digestion, but also the last part of physical digestion. Why would we have to remove our gallbladder? Well, you'll notice here, that's a really, really good question. And you'll notice here that when you have a gallbladder, okay, the gallbladder is a very small little actual, basically a shunt or a tube that goes from the actual storage area into the actual duodenum. And this can often get clogged. And when it gets clogged, it's excruciatingly painful. So what they do, because they can't unclog it, is they just go and they snip it shut here, and then they sew it shut, and then they snip it off, and they take it out of you, because you don't need it to survive.